Oh, okay.
Nope.
All right, so today's lesson is called Equations of Graphs of Proportional Relationships Involving Fractions. So we have written equations for graphs before. Now we're just kind of tying it together. So we're looking at proportional relationship graphs. We're building tables. We're just doing it with fractions. It's not that there weren't any before, but today's will all be fractions. So our first example is this. This is good. We were just talking about running. Here's another running example. Sam's mother has entered a 10K race. Sam and his family want to show their support of their mother, but they need to figure out where they should go along the race course. They also need to determine how long it will take her to run the race so that they will know when to meet her at the finish line. Previously, his mother ran a 5K race with a time of 1.5 hours. Assume Sam's mother ran the same rate as the previous race in order to complete the chart. Create a table that shows how far Sam's mother has run after each half hour from the start of the race and graph it on the coordinate plane to the right. Okay, so it wants us to show how far she has run after each half an hour. So let's start with our time as half an hour, and then we'll go to 1 hour, 1.5 hours, 2 hours, 2.5 hours, and 3 hours. Okay, I'm going to give you guys a little bit of time to complete the table. So you are given some numbers in the situation, so you can add the distance run where it is appropriate. You're going to need to figure out your constant of proportionality and then use that to build the table, all without using a calculator. So have fun with this. The graph, the numbers are all put in for you, so you just have to graph the points. Yes, question?
Can we do like miles instead of kilometers?
No, stick to kilometers, otherwise it won't work because your graph specifically says in kilometers. Yes, another question? Yes, you may work with your partner. All right. Okay, so as I walked around, I saw most of you had this filled in correctly. You had your 5 here because it tells us in the problem that she ran a 5K race with a time of 1.5 hours. So most of you put that 5 here. A lot of you jumped to this last one and filled this in next. Raise your hand if you did that. Okay, Caden, why did you do that? Why did you decide to fill in the 10?
Because it said she ran a 10K race and 1.5 times 2 is 3 and 5 times 2 is 10.
Okay, good. So 3 is double 1.5, and if we double 5, we get 10. So a lot of you jumped right to there. In order to find this unit rate one, the best way to do it would have been to find the constant of proportionality. So if we take y over x, we have 5 divided by 1.5, or you could actually do 10 divided by 3. That's kind of easier, but let's go ahead and do it this way. So we'd have 5 over 1 times, it would be 2/3, which is 10/3. So the constant k for this table is 10/3, and I'm going to leave that as improper because it makes it a little easier for me to work out. So then I can take 1.5, or not 1.5, I'm sorry, 1/2 times 10/3, and I would get 5/3, which is 1 and 2/3. For 1, it would just be 10/3, so that would be 3 and 1/3. What would it be for 2? I know some of you had different ways of doing it too, which all seem to work out. Yes? 6 and 2/3, yes, good. And this one? Go ahead.
8 and 1/3.
Good, 8 and 1/3. Okay, any questions about how we filled in the table? I know some of you were thinking things like one pair I talked to said that they got this 1 and 2/3 by dividing this by 3, because this was 1/2 times 3 was 1.5, so they just divided 5 by 3 to get 1 and 2/3. And that worked also, and then you could just build up on the table since it's going up by the same amount. But the foolproof way, I guess, of figuring out a table is to find the constant and multiply by the constant. That way, if it doesn't go up by the same amount on the left, you're not going to get mixed up by what's on the right. Okay, how many of you got so far as to graph it? Okay, let's just do it real quick. If you didn't do it yet, you can kind of do it along with me. Would we have a 0, 0 on this point? If 0 hours had passed, would she have run 0 kilometers? Yeah. She didn't get a head start on the race. It might be different if she had some sort of handicap where they said, okay, you get to start at the 1K mark or something like that. Then it wouldn't be true that she's at 0K at 0 hours. So after half an hour, she's running 1 2/3. So you have to kind of estimate 1 would be in the middle, and then you have to imagine this little part split into 3 parts and go up about 2 of those parts. And it's really hard for me to see that on my board. 1 goes with 3 1/3. So again, we go to 3, and we go just a little past it. 1 1/2 goes to 5. That's right in the middle. 2 goes to 6 2/3. That's going to be maybe about there. 2 1/2 goes to 8 1/3. And 3 goes to 10. That's nice. That one lines up. I think this point's a little off. Maybe that one a little bigger. That's leaves a little bit to be desired. What are some specific things you notice about this graph? Bella.
Well, it's not a straight line, but it should be a straight line. But it's
Yeah.
a straight line.
That's good. Mine is not quite a straight line, but if I had done a better job, it would be a straight line, right? Katie?
It is proportional.
It is proportional because it's a straight line. Well, through the origin, so it's a straight line through the origin, so it is proportional. What is this graph relating? What 2 quantities is it relating? Ava, why am I having trouble, like, instantly recalling everyone's name?
It's the time to the distance.
Yeah, the time to the distance. Okay, good. Part B is kind of a vague question, I guess. What is the connection between the table and the graph? Anyone want to take a stab at answering that? Allie?
They are both representing how many hours it took for the distance she ran.
Good. I would word that a little differently, and I would say they both represent the distance covered for the amount of time, because distance is dependent. But yeah, that's what they're looking for, that they both show the same relationship, they both have the same constant. Okay, part C, what does the ordered pair 2, 6 2/3 represent in the context of this problem? Emily?
In 2 hours, Sam's mother can run 6 2/3 kilometers.
Good. After 2 hours, Sam's mother has run 6 2/3 kilometers. If we were to write an equation for this situation, what would our equation be? This isn't on your notes. Eva?
It would be y equals, you want me to change it to
No, you don't need to.
10 over 3.
Good. Y equals 10 over 3x. Now, it actually tells us to use these letters. So if we use those letters, what would it say?
D equals H, or 10 over 3.
10 over 3h. Good. Okay, number 2 gives you something similar to work on. So bell's going to ring soon, and you can take your break when it rings, but I want you to start working on example 2 with your partner, and then we'll go over that briefly after the bell rings. Okay, first let's fill in the table. Ava, what were the missing values in the table? To go with 1, we should have had...
For 1, I had 8.
Good.
And then with 16, I had 2.
Good. And you can get those values just from looking at the graph. We have here the point 1, 8 and 2, 16. So you didn't need to figure out the constant of proportionality for the table in order to do this. Okay, what is the unit rate for cost per pound? Emily?
The unit rate is $8.
Good, $8 per pound. No, I don't. Okay. So B, you should have $8 per pound. Okay, letter C, write an equation to model this data. Haley, what equation did you write?
Y equals 8.
Okay, y equals 8x, and that works. Actually, no, it doesn't, because over on the graph, it tells us to use W and C, so can you just change that to use those letters? Not quite. This is the y, C is the y. So start with C equals.
C equals 8.
Good. C equals 8W. So your calculations would still be okay if you used y equals 8x, yes.
If we, on a test, if we get y equals 8x, would that be incorrect?
I might take off just a little bit if it specified the variables. But if it doesn't specify the variables, then you can use whatever letters you want, as long as you say what variable. X and Y are assumed that they represent the x-axis, the y-axis, but because it's specifically telling you that cost in dollars should be represented by C, I would want you to use the C.
Because I'm so used to writing y equals something.
I know, I like X and Y the best too. All right, D, what ordered pair represents the unit rate and what does it mean? Madeline.
Which letter again?
D. Which ordered pair? Good, 1, 8, and what does it represent?
For every pound of mushrooms, it costs $8.
Good, good. Make sure you guys have that written down. I'm not going to try to write it up here. For every pound of mushroom, you pay $8, or 1 pound of mushrooms costs $8. Chris, what does the ordered pair 216 mean in the context of this problem?
For every 2 pounds you bought, yes, $16.
Good. Or you could just simply say 2 pounds cost $16. I'm going to keep it short because I don't have much space up here. Okay, letter F. If you could spend $10 on mushrooms, how many pounds could you buy? Charlie? You didn't get that far. Okay, let's see. Andrew?
1.25 pounds.
1.25 or 1 1/4 pounds. Can you tell us how you did that?
I went on the graph and
Mm-hmm.
I went in between the half and the whole, and I went in between.
Okay, so you went to 10 on the graph. You saw that that was between 1 and 1.5, so you went with visually. Okay, good. You can do that some of the time, but we can't be sure. You ended up being right. It was exactly halfway, but sometimes we can't be sure if it's exactly halfway. What would be a better way of determining that? Eva?
I have a question.
Yes.
What was the answer then?
1 1/4 pounds.
But it's asking how much money 30 pounds of mushrooms.
No, this is letter F. If
Oh.
you could spend $10 on
Oh,
mushrooms, how many
okay.
pounds could you buy? Carly?
I did 10 divided by 8.
Good, if you do 10 divided by 8, because if you use this equation that we wrote up there, if the cost is 10, then our equation says 10 equals 8W, so you need to divide both sides by 8 in order to get the weight of the mushrooms. And 10 divided by 8 is 1 1/4. So that goes along with what Andrew thought it was, so he's definitely correct. Yes?
I looked at like the 8 and then the 12, and I thought like the 10 would be in the middle.
Yeah, so you were thinking about it more than just eyeballing it, but thinking about how that would be in the middle. Good, yeah, that worked. Okay, G, what would be the cost of 30 pounds of mushrooms? Jack?
The cost of 30 pounds,
Mm-hmm.
I got $240.
Good, and what did you do to get that?
I did 30 times 8.
Good, 30 times 8. If you use the equation, you'd have cost equals 8 times 30, and you would get $240.